Good luck. All right. Well, hello, all of y'all. This talk is titled "You Can't Get There From Here." I'm on like 36 hours awake right now, so if there's some rambling or incoherence, I apologize. Hopefully by the end this makes sense. This talk is kind of about client diversity. It's also about a project that I've been working on for a long time. Here we go. That's me. I work for the Ethereum Foundation. I build things. I've been doing this for a while. So what is the Portal project? For anybody who's heard me talk about this before, there's a little bit of naming change here. You may have heard this called Portal Network. Switching how we're talking about this just a little bit. For me, this is very much my white whale. I've been at this since I started quite a few years ago. Hopefully the whale doesn't eat me. This guy, back in 2016, I had the bright idea that I was going to write a lightweight Ethereum client. I've written a lot of Python in my career. It's where my expertise lived for a long time. And we sat down and it went great. We spent 5 years working on this. Didn't understand the protocols that we were going to build on, hadn't built peer-to-peer networking protocols at the time. I'd just gotten done kind of writing this beautiful Python EVM. And we get into Dev P2P. Dev P2P is the peer-to-peer networking protocol that all execution clients are built upon. And as we implemented the protocol, what we ended up with was something that looked a lot like Go Ethereum. It looked a lot like Geth. It turns out that when you go to implement an execution layer client and you do so on Dev P2P, which is what all of the execution clients are based on, you end up with something that looks a lot like Go Ethereum. Roughly 2 years into that, we realized Python is kind of slow and we can't keep up with block times, that we're struggling to make something lightweight. And then we spend the next 2 years or so kind of iterating in every direction we possibly can, trying to use LES, trying to use novel syncing strategies, trying to figure out, can we build something that's lightweight? And ultimately, this is the conclusion we came to. I pulled this phrase from a book that I read recently called The Power. I really like it. It's this concept of trying to transform a system that kind of doesn't want to be changed, that is maybe stuck in a local maximum, that has to get worse before it gets better. There being lightweight access to the Ethereum protocol, and here being the existing peer-to-peer infrastructure that we have today. So let's talk about Dev P2P. Dev P2P is actually a generic peer-to-peer networking protocol, very similar to Live P2P. I'm going to talk about it generically as if it's Ethereum, but there's these sub-protocols called ETH and LES. Dev P2P... There we go. It's not, though. Oh, it is. It's just a different color. Neat. All right, here we go. Man. Pew, pew. There we go. So the ETH protocol in Dev P2P is the foundational layer for all execution Ethereum clients. And at its core, it is a very simple transport layer between full nodes. Full nodes being these guys. It has these kind of networking primitives for syncing the state, for asking for block number, whatever, or the receipts from that block, or things like that. And then there's a couple of things for following the head of the chain. A lot of it is about freshly installed clients becoming full nodes, after which they use much smaller subsets of the protocol. But full nodes are these big, heavy things. I love this picture. I've used it in my slides too much, but I love it. Being a full node is a very big, nasty, heavy thing. I don't run one. They're too big. I don't want that software on my laptop. It eats the whole thing. But this isn't a fault of the execution clients. This is what dev P2P makes you do. If you implement what a full node looks like, if you implement the protocol as it's designed for the ETH protocol in dev P2P, this is the end state. And the conclusion that we came to is that dev P2P is too demanding. Dev P2P demands full nodes. The dev P2P ETH protocol is built on this fundamental assumption that you can just talk to any node at all in the network, and they will be able to return any piece of this data, any piece of history, any piece of state, that sort of thing. If you want to be part of that protocol, you must be that tall to ride, and if you are not, you're this sad little girl. Dev P2P is too demanding because Dev P2P says you must be a full node, and it is unreasonable to expect normal people to operate full nodes. And so this is what the world looks like in kind of the Ethereum protocol today. If you want to access Ethereum, you have roughly kind of these two choices. You can do the heavy thing, which, you know, there's some hobbyists out there that do it, and if you run infrastructure, you might do it. But everybody else lives in this kind of like privacy-sacrificing, centralized, brittle thing, which is centralized providers. These are your options, effectively. I'm glossing over LES. LES is the Light Ethereum subprotocol. It is not delivered on lightweight protocol access. LES depends on full nodes. We have this recurring theme of dependency on full nodes in Ethereum's protocols. And being a full node in the LES network, pew pew, is like this. You get hammered by all of the light clients just demanding data from you and demanding data from you. And there's no benefit to you as a full node. And even as a light node, there's nothing you can do to contribute to that network. LES has not delivered lightweight protocol access. It is decentralized, however, it is decentralized around full nodes serving all of this data. You can't get there from here. We spent a lot of time trying to build lightweight protocol access with the protocols that we had available to us. This is the conclusion. So, out of all of that work, we came up with some design principles around what, if we can't do it with these tools, what tools do we need to be able to do this? This is where the Portal project came from. Things like Infura, Alchemy, those are your centralized options. LES is decentralized, but each one of the centers of these stars is a full node getting just hammered. We went towards this distributed model. We wanted to eliminate this kind of tiered system of full node or not full node or anything like that. We wanted a homogeneous network where all of the people, all of the participants in it are able to contribute, and much like BitTorrent, that the small contributions of many add up to a large amount of network capacity. We needed to build something in this corner of the graph where nothing exists, something that is lightweight and decentralized and lets you actually get at the Ethereum protocol. So, what is it? The Portal project is a new set of peer-to-peer networking protocols. It's built on the Discovery v5 protocol for those of you who care to get down in the weeds of things. We took a page from the way that the beacon chain and kind of consensus specs and clients were built, with a focus on understanding what kind of resource requirements our networks and data structures and everything we're going to put on our clients, so that we could make sure that being a participant in these networks did not have those "you must be this tall to ride" sort of filters in them. We needed to build something that was friendly to be run on people's boring consumer laptops and the old Android phones and Raspberry Pis. And what the Portal project is a set of peer-to-peer networking protocols that implement a distributed storage network for the core of the execution layer Ethereum data. The ability to follow the beacon chain, because that's how you follow the chain, the history of execution, headers, bodies, and receipts, and the state. Here's a mouthful. Globally available, highly accessible, massive cooperative archive node. Globally available, it's a peer-to-peer network. If you have access to like standard sending UDP packets, you can be part of this. Highly accessible in it being designed to be friendly towards low resource devices. Massively cooperative in that those low resource devices can contribute back to the resources of the network. If you want to show up with 50 megabytes of hard drive space to give us, wonderful. And we're shooting for it being an archive node, essentially being able to access arbitrary historical state, current state, historical history. This is like the base data set for Ethereum, and you can build just about everything else on top of that. Cats. So where are we? When can you use this? You can start using some pieces of it now. We have the history network, generally feature complete. We're in the bug squashing stage. Teams are starting on Beacon Chain, on our kind of Beacon Chain subprotocol for being able to follow that. And similarly state. I don't know, I should have titled this Lies and Projections for Software Delivery. It'll be done when we get it done. We're delivering stuff as we go. I just want to acknowledge that I didn't talk in any detail about the details of how we do this and how we store the stuff. That's not exactly what this talk is about. If you want to talk about the details of how the networks are built, I would love to do that. I just don't want to lose half the room getting into nitty-gritty details. This is what I really want to talk about, because what this project is kind of these two sides of the same thing. Lightweight protocol access is very much at the core of what we're going for. But the piece that is kind of under the surface is execution layer client diversity, which has been a shit show for quite a while. This is what our execution layer network looks like, that giant blue Pac-Man eating everybody else's Go Ethereum. This has improved over the years, but not by a lot. And I have a lot of ideas and opinions why. These are opinions. Take it or leave it. But if you want to fix client diversity, you have to beat Go Ethereum. I'm using intentionally adversarial language here because it's more attention grabbing. But nonetheless, this is the truth of it. If you want client diversity in the execution layer, you have to beat Go Ethereum. So how do you do that? One thing that we tried to do when we built our client, and that it seems some of the other clients are sort of trying to do, that's not entirely fair, is be better at being Geth than Geth is, which is a losing game in my opinion. Geth has had years to be good at being Geth. Heck, they are Geth. And it is my understanding that these two clients just look a lot like Geth. It's not their fault. If you remember, I said we went and we implemented the dev P2P ETH protocols, and we got something that looked a lot like Geth. That's what the network makes you do. So I think if you want to beat Go Ethereum, you have to play a different game than them. Aragon is sort of playing a different game. If Geth's somewhere here in the middle, and the Portal project is going off in this direction, saying, let's move the complexity into the networks, let's take it out of the clients. Aragon said, we're going to sprint this direction, and we're going to make a really high-tech piece of software. Aragon is not a lightweight client to run, but I do think it differentiates itself more than the other clients from Geth. They're still not winning. I think if you want to beat Go Ethereum, you have to play a fundamentally different game. And this is where the rub comes. I think that what we are doing with the Portal project is a fundamentally different game. We'll see. But here's my logic for how I get here. If you want client diversity, you need diverse clients. As in, you need clients that expose a diverse feature set, different feature sets that focus on doing different things well. Otherwise, you're just playing a zero-sum game against the same set of users. If the clients aren't different, they're just all fighting for the same set of users. And if you want diverse clients, you have to have flexibility in how you build your client. And as I said, the network says you must do these things. And so if you want to be able to have flexibility in how you build your client, you need some networking protocol changes. And it turns out that since Geth owns the network, if you want networking protocol changes, you have to get Geth on board with those. And this just mostly doesn't happen. We've been in roughly the same state for years. It has improved recently, I will say that, but that Pac-Man has been eating the other clients for a long time. And hence, you can't get there from here. I don't think that you can get execution client layer diversity using the protocols that we have. Hence, trying something new. This is what the Portal project is. We're aiming to deliver lightweight protocol access, and I think we're also looking at hoping to fix client diversity by allowing execution clients to do something different than what they've essentially been forced to do for a long time. Questions? How's what going? I mean, I'm 40, I got divorced, and in the middle of some kind of midlife crisis. Oh, sorry, how's this going? It's going great. I've got 3 wonderful client teams that are engaged and excited about this thing. We've been kind of hidden working on it for a while on our own. I'm cautious to approach the execution client devs. They're busy with other things, and frankly, I've been a little burned in the past in them not getting on board with this stuff. And I understand why. They're busy with their own things. It is hard to run an execution client. But the project's going great. We have the history network largely up and running. It's really cool to be able to grab data out of this network and to start running nodes and seeing them scoop up data and serve it to other people and to have the thing actually working, because this thing has lived as a theoretical thing in my brain for too long. So.
What are other ways to implement this like clients? Would a CK approach help in the sense that you would just have like a light node verifying the transitions, and then the data availability problem you shoot it outside of Ethereum?
Well, so first of all, I don't know what you mean by living outside of Ethereum, because it's a little ambiguous there. In theory, yes, ZK stuff can help. Ultimately, we've just focused on kind of the Nintendo approach to things, which is old, boring stuff that's known to work, if that makes any sense. All of the data that we serve and retrieve from the network is served in provable formats. Right now, instead of going for things that I didn't know and didn't understand and didn't know how to build, I went with pretty basic stuff like Merkle proofs and things like that that I know how to use. There's got to be so much room for improvement here, but we went for something that we could run for, deliver with no unknowns, with the knowledge that as soon as we got there, we would start iterating on it and making it better.
Cool. So you said you have 3 clients currently in progress. Those are execution layer clients, to be clear, and like the.
These are brand new clients.
Different
we call
clients.
them portal clients.
Okay.
I think that the distinction between an execution and a portal client is going to get fuzzier and fuzzier as time goes on. We'll see. One's built by the status team. It's called Fluffy. They're kind of our inroad to execution clients because they have Nimbus ETH, which is their execution client. We've got one by the JavaScript team inside of the EF, and that one's largely experimental, but looking at things like being able to run them in a browser and fancy stuff like that. And then one built by what is effectively my team in Rust, which is just designed to be kind of like this kind of core system level I don't know what else to call that.
Cool. Is the ultimate idea that they also start contributing to the decentralization of Ethereum and they end up in that pie chart that you showed up there before as well?
The way that I think and that I hope this affects execution client development is that when these networks are up, running, live, serving all of that data, and the cost at getting at it is just really low-level network participation that doesn't cost you much at all, that's going to be tempting from hopefully, from any of the execution client developers as they look at, man, it'd be really nice to ditch all of these old block receipts and implement EEP 44444, however many fours are in there, and free up hundreds of gigs of disk space. I could just fetch this data on demand from Portal. That's the hope. Thank y'all. Happy to talk with any of you about this.